Right, thank you, Aaron, appreciate it.
Okay, thank you. Take care. Bye, guys.
Okay, everyone, what are we up to today? We are carrying on chapter 5 on loops. Last time we covered while loops. I'll spend a hot minute on that right now. Then we will get into for loops. Different use case for why we would use for loops, but good to know both of them. We'll do a comparison between for loops and while loops. You were introduced in Zybook to this concept of reversed. Hopefully you have some recollection of that. We'll go into some details there. And then we'll close it out by looking at the concept of break and continue, which I mentioned very, very briefly when we did the last sort of code along. So for those of you who walked in a little bit late, Darian is here. The workshop is over in 354 over in Martin. So if you are interested in speaking with her, she will be there also for office hours. So right after this, I'm walking over there. If you want to walk with me, great. So that's okay. Recap. Where were we? So we introduced Monday's lecture talking about a very simple game, guess which fruit. And we looked at how we would do it in an if statement. It was a really boring game because you only got one guess and you had to run the program again. So we introduced this concept of a while loop where basically we would execute this statement or every statement that's indented in the while loop over and over and over again until this condition changed. So in this particular case, we knew that fruit was kiwi, and until the user put in the word kiwi, we would just say try again, try again, try again. When we look at the syntax of this while statement, again, you're going to see a lot of repeats here. Once you get your head around the way like if statements work, you kind of get the syntax for while statements. You'll kind of get the syntax for loops. When we get into functions, it's all kind of the same thing. So, the general pattern is we have some condition. We have an indentation. Again, that's a peculiarity of Python. In the case of an if statement, it just does that stuff once. In the case of a while statement, it does that over and over again. Both have this colon at the end. You're not going to get very far in your programs. It'll block at you real quick if you get that syntax there. The key difference here is the semantic difference between if and while, right? If is a one-time guessing game. The user gets one chance. Input, guess the fruit. If they say yes, kiwi, awesome, they won. If they don't guess it, they just get nice try, and the program ends. Right? Very boring game. The while loop goes over and over and over again. It's imperative that something affects this condition. So something either has to change guess or fruit. Otherwise, you end up in an infinite loop, right? And that loop never exits. Okay. Relative to today's discussion on for loop, I want to call you back to this, which we looked at, a couple of days ago in a previous lecture, the in operator. This is critical for loops. So if we remember the in operator, we had this very simple example here. I had the string word, a variable named word that had the string banana in it. And I could say if the letter N is in that word, I'll print out found an N, else did not find an N. So is this character in? We also looked at the inverse of that, not in. If, H not in word, that would return true. Where this becomes very useful in loops. Most of the time when you're kind of looking for stuff in a character, in a string, you do that a little bit. When you're looking for things inside lists, inside sets, inside dictionaries, you're doing that all the time in programming. You're constantly interrogating these sequences or collections. So as a reminder with this in function, I have a list of fruits, and I can say if the string banana is in fruits, return found a banana, otherwise did not find a banana. All right? And that would be very similar syntax if we were looking at a set or if we were looking at a dictionary, and that would return whether that key was in the dictionary. Okay, so for loops. Let's introduce this syntax. Looks kind of suspiciously like if and while, right? We have a keyword here. Instead of if or while, we have the keyword for. Here, we have a condition. Just like with a while loop where we would have while I is less than 3, we will say for letter in cat, right? Or for fruit in fruits, something like that. But the condition here, at least in Python, 99% of the time is in an in construct. There's some edge cases which we don't get to in the intro course. For people who have used other programming languages, you know, Java, JavaScript, you would use different conditionals inside a for loop. But again, we're dealing with Python here. So Python really deals with this something in a collection or a sequence. Okay, so how does this code work? So let's pretend, you know, we're inside the computer here. So the interpreter is going to say for letter inside cat. So it's pointing at the letter C. It's going to fall into this loop and print the letter C. Because I've not exhausted everything that's in that sequence, it will now move to the next character, the A. So it's going to print that letter, A. You see where this is going? Moves to the right, the letter T, it prints out T. When it's exhausted all of the elements that are in that sequence, or in this case, the characters that are in the string, it drops out back to this level of indentation and prints out done. So very similar to what we saw with while loops and ifs. So let me just bring up both of these side by side. This is the similarities and differences syntactically. So we have a different keyword. We have while versus for. Here we have just some vague condition. 1 less than 2, I less than 10, whatever it is. And then we do something. And we can do multiple lines of code with that indentation. The for loop syntax, again, you're going to see this. For something in something. For a character in a string. For an element in a set. You know, whatever you want to call those variables. Go ahead and do something. This, do something with the item. Let me just call that out real quick. Usually when you're dealing with a for loop, you're trying to do something with the things you're iterating over. Either print them out, add them up, you know, do something with them. How should you think about while versus for conceptually? And I think this is actually a pretty good example. And if you're ever sitting down to do a coding problem, like for an exam or a test, there's going to be some cases where I'll say, please use a for loop, please use a while loop. Sometimes it's up to you, right? And again, I think that's the beautiful part about computer science and what we do. You can pretty much solve any problem with the same while loop or for loop. Player's choice. But some of these contracts make more sense than the other one. So like a while loop, think of this scenario. Continue driving until you run out of gas. Yes, you have a gas gauge in your car, but you know with some degree of certainty like how much longer you have to go. And I guess take away that, you know, 10 miles till empty, 20 miles to empty thing. If you just have the gauge, you might go 10 miles, you might go 2 miles, you don't know. Versus a for loop. A for loop is more like, you know, okay, I know I need to go 12 miles to get to my exit. You can count down 12, 11, 10, 9, 8. It's not like it's ever going to get out of sequence. 12 miles away is 12 miles away. So continue driving until you reach 12 miles. So similarities, they're both used to repeat code over and over again in a loop. Think of the while loop. That continues until that condition is no longer met, right? You're incrementing I, you know, something like that, versus a for loop, which just says, I have a list of things. Once I've gone through that whole list of things, I'm done. I'm putting side by side here the same code. This will do the same thing. Arguably, the one on the right is maybe a little bit easier. It's a little bit neater. It's a few less lines of code. If I wanted to loop over and print out each character in the word banana, this is the way I would do it with a while loop. Versus a for loop, I would do it that way. So over here, I didn't have to like contrive this index variable. I didn't have to predetermine the length of banana, right? Over here, it just assumed it. And again, if we walk through this, we're not going to waste the time on that. That would basically do that as we ran it. And as that ran, we would do the same thing. Okay, so I'd rather us spend more time in the coding blocks than looking at slides. So we will jump into assignment 5, some of these freebie questions that we have here. If you didn't see, I did post in the announcement last night for Monday's lecture. I have released the big point questions here. Run length encoder worth 23 points and a pizza rewards program worth 70 points. That will be due, I forget the deadline, I think it's next Thursday maybe. We'll see at the end of class. If you do have questions in lab, you can work on it. This is going to be a very easy lab this week. There's only 3. There should be no excuse to not finish the homework, the lab, possibly even the assignment inside the lab. Okay, so let's just start with the basics here. This is the one we've kind of seen over and over so far. I have a string, which is this particular song, and I'm going to say for each character in the song, print it out. Notice I'm just putting a dash in between each character just to make it easy to see. Right? So this went printed the R, then a dash, then the I, then the dash, then the G, then the dash, H dash, T dash, space, dash, right? And so forth. There's no magic to the word character here. Oops. I get the callable. I could do that, and that's just as acceptable. And again, this is probably one of those cases where it would be okay to have a crappy variable name if you kind of knew what you were doing. Okay. Iterating over a collection. So here I have a list of songs, and thank you all for your songs. I farmed them from your assignments. So I have a list of songs. Here I'm saying for song in my songs, print it out. There we go. Again, no magic to this word song. I could have said S here. That works. Okay. Iterating over a dictionary. So here I have a dictionary where I have the songs to the artist. So this is the song, this is the artist. This is the song, this is the artist. The syntax for that should look pretty familiar. For song in artist to song. So let's see what that does. Aside from that garbage. So this prints out the song, right? And notice what the song is in this case. It's actually the key. You know, if I wanted to be a little bit more generic, I could have just said key. And then you could have saw that here look like that. But I'm printing out the key is by that artist. Space it out a little bit. Oh, that looks like shit. Okay. We'll learn formatting a little later. Okay, your turn. So, let's have a little fun here. And I'd like everybody to actually do this. I'm going to pause for a minute while we do this, I'm going to ask that you all do this. If you didn't bring your laptop, or if your friend next to you has one and you want to pair up, be my guest. So I've modified a little bit this collection that we've been playing with, this songs collection. I've simplified it just a smidge. So I have a name tuple song. I've gotten rid of that duration name tuple, and I've just put in the number of seconds for that song. For the category, it used to be comment, I put in like a legit category. If I have time later, maybe I'll show you. This was like a great use of AI. The way I did that, because people had like a lot of cool comments, like, you know, my favorite song, or my first song, or my second song, something like that. I took all this and I dropped it into Gemini, and I said, Gemini, review these songs and update the category with a more accurate description. And I think it did a pretty good job. But neither here nor there. You have a dictionary called catalog, where there's a key here, and the value is a song. Seconds is an integer, and category is some string. So over back here in this exercise, let's see what we want you to do. The song tuple we've been using has been updated to include an accurate duration for each song. It's now stored just as seconds. Using a for loop, please use a for loop, iterate over the elements in that dictionary and calculate how long it will take to play the entire catalog of music. So each song is going to take n seconds to play if I played song after song after song. So write a for loop somewhere in here between lines 50 and 51 and update total time seconds such that we get the total number of seconds that catalog will play for us. So have at that for like a minute or two. And then when we're done, I'm going to ask somebody just to come in and key in your answer. This should be a very simple for loop here. So have at it. And if anybody thinks they got it, if you want to come up and key in the answer, more than happy to have you do it. Yep.
You got the for catalog as well.
Oh, yeah, good. You probably will. You probably have to say from songs, import catalog. Probably the first thing we have to do. Yep. Well, yeah. All right, does anybody think they got it? How should I start out? How do I start out a for loop? For. And we're iterating over the minimum, yeah, songs or keys, something like that, in catalog, right? Okay. So if I want to access that song, the current song will be something at that key. Maybe I'll make that singular. Okay. Let me just take a baby step here. Let's see what happens if I just iterate over the keys in that catalog. Let's see what I get. Cool. I got a whole bunch of song tuples. Okay, but I don't want the song tuple. I want to add up the durations. So what should I do there? What should I do to total time seconds? Well, I've got two options here. I can either say, what was the previous value plus the song, and what field do I have on here somewhere? Probably duration. Sure. And let's watch this grow. Okay, so I started out with 249 seconds, 468, 741. Okay, that seems to be working. As I mentioned, we want to get really comfortable with this notation, plus equals, because we're lazy programmers. Don't want to waste electrons. Okay, so let me just comment out this. Let's see what we get. The total catalog will play for 1 hour, 11 minutes, and 35 seconds. This is some of that div and mod magic that's breaking up those seconds to hours and minutes. But just a refresher, this stuff comes up all the time. I think we saw it in the last lab, right? When we were doing counting dollars, quarters, nickels, dimes, right? Anytime you're sort of scaling something, mod and div become very, very useful. Okay, so that is the simplest of simple for loops, really. Let's do one a smidge harder. So I'll comment it out. Okay. Part 2. The song tuple we've been using has been updated to include an accurate category. So my tuple has a field on it called category. Using a for loop, iterate over the dictionary and calculate the total time for each catalog or for each category. So I want to know, I'm going to play R&B for an hour. I'm going to play rock for 30 minutes, something like that. And then I want to print out something like this. Rock for 35 minutes, 22 seconds, pop for 9 minutes and 2 seconds, something like that. So let me walk you through how I think through this problem. First off, we learn our lessons from the last one. We got to import. So from songs, import catalog. Okay. What is this asking me to do? Calculate the total time for each category. Inside programming, there's usually something called patterns or design patterns. Sometimes there's things called anti-patterns. This is called the accumulator pattern. We're accumulating something. We're adding up these dates. We're sort of, adding additional value that can only be derived from adding things up. So I'm going to have a loop, obviously. For key in catalog, colon. Let's get our song. So we'll say catalog key. Let's get our category for the song. Where's that category? Or what do I call it? Yeah, category. It's an attribute on the song. So there's the song, there's the category. Here's the time. Song.duration, something like that. But I have to think about this for a second. Up here, I needed to accumulate everything into a single variable called total time. So I was doing it for the whole catalog. What data structure might I want to use to store a whole bunch of different times for a whole bunch of different categories. What might make sense? A what? I think I heard it. Somebody say dictionary? I'll say dictionary. I'm going to create a dictionary called category to time. And it's an empty dictionary, so I just say open, close, brackets. Okay, that's a little complex here. So I have my current song. I know what its category is. I know what its duration is. I don't know where to accumulate it at. So I need to look. So I'm going to say if category in category to time, then I know I've already seen a song in the catalog with this category. I can say category to time, whatever the name of this category was, equals that time. Pardon, plus equals. I want to accumulate it. Else, I have not seen this category yet. It's a new category. So there's nothing to plus equal to, but I can do an assignment. Okay. So what I'm going to do here is I'm just going to put a print statement here. I'm going to see what this groovy thing is doing already. Print category to time. Okay. So look at this. R&B 465, dance hall 219, hip hop 1,860, soul R&B 197. Cool. It looks like I've constructed a dictionary where the key is the category and the value is how long all the songs that are R&B, what they all add up to here. So to round this out, if I want to print out something nice like this, out here, I just need another loop. For category in category to time, print, there's my category, there's my time. Let's see what that does. Punk rock 151, trap 151. Something looks funny there. They're all 151. I think we screwed something up here. Let's go back to the previous step. Category to time. So we have all different values here. Okay, so where did we go wrong here? If anybody sees it before me, let me know. Ah, I know where we went wrong. Here, I just printed out this random variable time, which was set up here. I actually wanted to get my value out of this dictionary. Let's see what that does now. Okay, that seems a little bit more reasonable. Cool. All right, last thing here, I wanted to print it out a little nicer. You know, again, this is more ideally what you want to do. You want to do something like this. Category is a variable. I wanted like a colon or something. And then I wanted to have this variable here, right? Okay, we can run that up. All right, I've got those seconds. We want it a little bit prettier, so I'm going to go up here and steal this code, mins and seconds. Let's paste that down here. So here I'm going to take this groovy thing here, paste that in there. My mins, seconds. Okay, R&B, 3 minutes, 17 seconds, punk rock, 4 minutes, trap. I got Bounce Shell. I don't even know what that is. It's like the most popular one. So I got some cool stuff there. Maybe I want to start format this a little bit nicer. Maybe I want to say, you know, 0D or something, or 02D. Yeah, that's a little bit nicer. Let's use that over here. Cool. What about this category? I don't know if y'all remember this one. We're going to learn this next week. I can format a string. I can say I want it to be a minimum length. Oh, look at that. Stuff starts flying up pretty nice. Let me just futz with that a little bit. Let me just say, pad that out to 15. Cool. That's a little bit better. I don't like that colon there, but not the worst thing in the world. Okay, so I'm going to claim success on this exercise. You all should be able to see, by the way, at party, because somebody asked about this. We do go through these in class. You should be able to see the ideal solution here. So if you aren't coding along, you can see what the actual solution should be. It might not match what I do in class because I'm legitimately doing this on the fly. This is stuff I did a week or two ago. So you can always just go to solutions on each one of these. And unless I egregiously screw up, you should not see the solution on the pointed ones. Only I should see those. Okay. So those are for loops. All right. We're going to do this relatively quick. Again, I get some feedback that this class moves fast. It does, but there's also the requirement that y'all read chapters before you come to class. And right now, I think we're at 12% have read chapter 5. So if this is fast, because you haven't done the reading. Everything I'm covering here is legitimately inside books. So the next topic that's covered is this concept of reversed. Becomes very, very useful for lists, but you can use it for strings. So add to your memory bank of functions you have. You have the function length, you have the function int, string, all those good ones. There is another function called reversed. Shouldn't be a big surprise what this function does. It takes the sequence you put into it and it puts it in reverse order. So if I want to iterate over this word in reverse, I can say for letter in, effectively reversed by string, and that will print out OLLEH. More useful when we get to lists. So here I have a list, 1, 2, 3, 4. If I reverse it, 4, 3, 2, 1. The only time I've ever seen the reverse, like from a natural language perspective, work out really well, is looking at some languages that are actually written backwards. So it comes in handy for that, but with strings, maybe not the most useful thing. Okay, so I'm going to pop over to EdStem to reversed. Let's take a look. This one shouldn't take us too long here because there's not much to this, but here is some string that I've created, and I'm going to print it out. And here's my loop. For character in reversed my string, print out each one of those characters. So some string that I created, that's this thing, backwards is this. Tetarak, I, tat, ritz, emos. Star Trek people, you can start speaking Klingon because that's kind of what that is. All right, let's code along. Your turn. New word for everybody, fun word. I learned this one. The following list contains, I'm going to roll the dice on this, semordinlaps. These are apparently words that if you look at the characters forward and backwards, they yield a correct word. So I have a list here of a bunch of these words. Let's iterate over this list forwards and backwards. So forwards. This really shouldn't be a big deal. We just learned this. For word in whatever the heck that thing is, print word. Okay. First word is stressed. Last word is gateman. If I want to do that in reverse order, I simply put reversed around my list. Let me just put a print statement here so we can be this separated. stressed, rewarder, deliver, drawer, gateman. And then the first one's gateman, the last one's stressed. Okay, that's pretty straightforward. Let's have some fun with these subordinate laps. So let's combine what we did in that first example and the first part. Let's iterate over that list, and then let's reverse all of those words. So for, word, in, and again, please embrace your IDE here. I don't even know how to pronounce that word, but the IDE knows that's what I want to do. Okay, cool. For, word, in that thing, that list. Now I want an inner loop. This is one of the homeworks that we were looking at earlier today. When you're doing some of these homeworks, it would behoove you to have a pen and paper to keep track what's happening in the inner loop, what's happening in the outer loop. So here's an example of where we would do that. So I'm going to say print, whatever, my word is, this is my word, and let me get rid of that new line and just put a space. I'm going to do another loop. For, character, in my word, print, C. And I'll put end equals there. Let's see what that does. My word is stress. My word, oh, this is crazy. Let's add a little cleanup text here. Put a print for a new line. My word is stressed. Stressed. My word is reworder. That's not exactly what we wanted to do. Didn't we want to reverse this thing? So we do reversed word. And maybe I'll just get rid of this space for now. My word is stressed. Backwards is dessert. My word is rewarder. Backwards is redrawer. My word is deliver. My reverse word is reviled, and so forth. So again, this reverse thing, hopefully it's relatively intuitive. You just put your list inside of it, and it just flips it around. Everything else you do is exactly the same, whether you're doing one loop or an inner loop, whatever. Okay, last concept for the day, break and continue. This is a very, very useful concept. Again, I had mentioned this in the previous class. Used to be called like kind of a go-to statement, which is not really used, but in a lot of cases, you don't want to continue your loop for either infinity, number one, or two, you don't want to continue it for your total number of times. So you use break to break out of the body of a loop. It basically, you never go through it again. As soon as you hit the word break, you go back out and you carry on with the rest of your code. So in this particular case, this was our guessing game, right? Our guessing game, I kind of re-engineered it here a little bit just to give the user 3 chances. So I didn't want this to go on forever and the user to guess forever. So the user had 3 chances. So I'm just have a loop from 1 to 3. But if the user guessed it right, I just broke out. I just say break. You can use break in for or while loop. It's the same. Continue is a little less aggressive than break. And what I mean by that is continue says, listen, I'm done processing this iteration of the loop right now. Immediately go back to the top. So in this particular case, I have an example where I want to print the numbers between 1 and 10, except for things that are multiples of 3. And I determine that by mod. So in the case, so I basically have a loop here that's printing out each one of these numbers. But if this number is 3 or 6 or 9, whatever, it's going to say, this number is 3. I'm going to just say the next number is 4 and go back here. Okay, 4 comes in. Is 4 mod 3 0? No. Okay, cool. Print out 4 and continue. This is some of the code we'll look at, so I'll leave it here for posterity, really. This is the same thing here. So, break and continue. Here's this very first loop we looked at when we looked at loop, this keep going loop. So instead of me relying on the value of this variable, I'm just going to say if the user enters no, I'm going to break out and terminate this loop. Keep going. Yes, yes, yes. No, boom, I'm done. I'm out of the loop. Part 2. Let's see what we're doing here. I'm creating 2 random numbers. One that is somewhere between 1 and 38. I have no idea what it's going to be. Then I'm going to create a max number that is at least min up to 60. So this is that concept of a range, right? So for each item in that range, that's going to be a number. If the number is mod 13, so if it's divisible by 13, I'm going to break out. Otherwise, it's not, and I'm going to continue printing. So because we got to import random. Okay, range was 23 to 52. 23 is not mod 13, continuing. 24 is not mod 13, continuing. 25, oh, stopping on 26 since it's mod 13. So you can see here, hopefully, the usefulness of this break. I'm using random numbers intentionally. If I just gave you a program here where I was like, min is 1 and max is 3, breakout when in 2, you'd be like, yeah, well, obviously. Here, I have no idea what these numbers are going to be. Right? I could have made this exponentially more difficult. You know, there's one level of difficulty more. My program's probably going to do, let me maybe make this 130 instead. Yeah, I'm doing a lot more loops here. So, all right. I'm going to jump down here to, and you can look at this later. There's a bunch of examples here, but I want to get to close out what we looked at the beginning of this module where we wrote this little password program. So we had this password program where we had a username to a password. And we said, okay, I want someone to try to enter in their password up to 3 times. And we kind of had this little sticky situation when the password was correct. Like, how did we get out of this loop? And I kind of stumbled a little bit in class. I didn't want to introduce break at that point. So I introduced this variable, right? So if I'm going to trace this through, I'm going to enter in Dan and 1, 2, 3. So Dan is the correct username. 1, 2, 3 is the correct password. So the first time this comes in, well, num tries is less than max tries, so 0 is less than 3, and not success. So success was set to false. So I'm right here. I just asked for the username and password. Is the username not in map? No, Dan is in there. Okay. Get the password out of there. Ah, does it equal 1, 2, 3? Access granted, success equals true. So my loop continued on down here, and then it came back up here and said, and not success. So I dropped out of the loop. To simplify this, I can get rid of this now. So I can get rid of success. I can get rid of this superfluous variable. And here, I could just say break. Dan, 1, 2, 3. And the code does the same thing. Right? So there's a couple other contrived examples in there, but I wanted you to see that come full circle with that example. So we will close out. Let me just figure out how the hell to get this thing out of full screen mode. Okay. So we've covered 4 loops. We looked at the difference between while and for. We looked at reverse, break, and continue. Thursday night, assignment 4 is due. So I guess you might have a little time in lab if you haven't knocked it out yet. Friday will be a quiz on branching. Here's the deal with this quiz. I want to give folks practice with that writing segment. So there will be 9 questions and 2 short answers. Okay. You only have to do one of them, but in this exercise, the bonus point is if you do both questions. So there's 9 true, false, multiple choice and 2, short answer ones. You may use your notebooks, you may use whatever things you think might help you on Friday. If anybody needs to take this quiz early, if you need extra time, if you think you're not going to make it to class on time, come see me. You can take it early in office hours or afterwards. All right, everybody. Enjoy Wednesday.
Yo, you know what? It's just